Okay, so let's see the next question. That is question number 8 from this paper. Okay, well, we got question number 8 here. So in question 8, it says a curve has equation y equals f of x, where x is greater than 7. Okay, the point P 4, 2, 4, x coordinate 4 and y coordinate 12 lies on the curve. Given that f dash x, the derivative of f of x, it is 3 square root of x plus kx squared, where k is a constant. Okay, fine. The equation of the tangent to the curve at point P has equation y equals to 10x plus c. Okay, where c is a constant. So that equation for the tangent to the curve at the point P, it's given. Okay, we have the equation for the tangent. Okay, now part A is asking to show that k equals to 1 over 4 in section 1, and in section 2 it asks to find the value of c. Okay, so we have f dash x, the equation for the derivative of f of x, and the equation for the tangent, and also we know the coordinates of the point P. Okay, so from the equation of the tangent we can find out the gradient of the curve. How? The tangent, it is at the point P to the curve, right? And its equation is given, so that means from the equation we can get the gradient of the tangent, and we know that the gradient of the tangent is the same as the gradient of the curve at that point, that is at the point P. Okay, so we can write the gradient of the curve, part A. So part A1, gradient of the curve at the point P. So at the point P the x coordinate is 4. So f dash 4, this is equals to how much? The gradient, it is what? 10. The gradient of the tangent is 10. That means the gradient of the curve is also 10. So f dash 4 equals to 10. So we just need to put x equals to 4 into the equation of the first derivative, right? So 3 square root of x. So 3 square root of 4, then plus kx squared. So 16k equals to 10. We have just k as the unknown variable here. So 3 times 2, this is 6. So 16k equals to 10 minus 6, which will give you 4. And then k equals to 4 over 16, which is 1 over 4. That's it. We got the value for k. And in part 2, we need to find out the value for c. This is the value of c, right? Okay. So we know the coordinates of the point P. Point P has coordinates 4, 10, right? 4, 12, sorry. It's 4, 12. Okay. So point P is a point on the curve C, and the tangent we see here, it is at the point P. That means point P will also, the coordinates of point P will also satisfy the equation of the tangent, because point P lies on the tangent also. Yeah, so we can just put x equals to 4 into the equation of tangent, so that we get 10 times 4, 10 times 4 plus c, this is equals to 12. Then just make c the subject. So 10 times 4, it is what? 40. So 12 minus 40, it is negative 28. So the value for c, it is negative 28. Done. We got the answer for part 1, sorry, section 1, and also the answer for section 2. Okay, next, in part B, it's asking to find the value of the f dash x at P. Okay, so we already know the value for k, right? So just put the value of k into the f dash x. Okay, f dash x. So it's not f dash. Okay, it should be f naught x. Okay, f naught x. Okay, so for f naught x, this is 3 square root of x plus 1 over 4 x squared. If I'm not wrong, it is x squared. Yes, correct. Okay, so f dash x. Now we need f. I'm again saying f dash. It's f not x. Okay, we need to find out f not x. Okay, simply the second derivative of f of x. Right, the first derivative of f of x is 3 square root of x plus 1 over 4 x squared. Now if you differentiate the first derivative, you will get the second derivative, right? So to differentiate, we need to make the powers visible first. Okay, so 3x to the power half plus 1 over 4 x squared. Okay, okay, now we can differentiate it to get the second derivative of f of x. So if you differentiate, we know that the coefficient will be multiplied by the index of x. So 3 times half, okay, x to the power, and then we will subtract 1 from the power. Okay, okay, so 3 times half, x to the power half minus 1, and for the other one it will be 1 over 4 plus 1 over 4 times how much? 2, because it is x squared, so x to the power 2 minus 1. So the second derivative of x, we will get 3 over 2x inverse half, okay, plus half of x, just half of x. 2 minus 1, it's 1, so half of x. Okay, so the second derivative of f of x, we got 3 over 2 x inverse half plus half of x. Okay, now the question is asking to get the value for the second derivative exactly at the point P. Okay, so I'm just writing it in a simplified form. This is the simplified form. Okay, inverse half means the x will go to the denominator, right, because it's inverse, and its power will become half. So if the power becomes half, it is square root of x, simply. Okay, so at P we know that the x coordinate is 4, so f dash dash f not x, this is equals to 3 over 2 square root of 4 plus half times 4. Okay, so that would be 3 over 4 plus 2, right? So 3 over 4 plus 2, it is 11 over 4, and that's the value for the second derivative of f of x at the point P. Done. That's the answer for part B. Now part C, the last part of the question 8, it's asking to find f of x. Okay, so we already know f not x, right? We already know f not x. So for part D, isn't it D? It's C basically. Okay, it's C. So f not x, it is, what was that? It was 3 square root of x plus 1 over 4 x squared, isn't it? X squared, yeah. So this is the first derivative of f of x. Now from there we need to find out f of x, right? We need to put out the not sign, right? So f not x, this is the derivative. So we need to find out the original function from the derivative, and we know that if we differentiate the original function, that is f of x, we get the derivative, right? So if we go the reverse way of differentiation, it is integration. So if we do integrate f not x, we will get the f of x. We just need to go reverse. Okay, so f of x will be integration. It should be in indefinite integral. Okay, no limit will be there. So 3x to the power half plus 1 over 4 x square, okay, dx. We are just integrating to get the f of x. Okay, so integration. Okay, we need to go reverse, right? So in integration, what we do, okay, at first in differentiation we subtract 1 from the index of x, right? So in integration we will do the reverse. We will add 1 with the index. Okay, in differentiation we multiply the coefficient by the index of x, but here in integration we will divide the coefficient by the what, index of x. So this is half plus 1. Okay, same goes for here. 2 plus 1 plus 1 over 4 divide 2 plus 1, and never forget to add the arbitrary constant. Okay, so now you just need to simplify. Half plus 1, this is 3 over 2. So 3 times 2 over 3. So 3 over 3 over 2. 3 over 3 over 2 x to the power 3 over 2 plus x cube and 1 over 4 over 3. So that will be 1 over 4 over 3 plus c. So the equation will be 3 times 2 over 3, which is just 2x to the power 3 over 2 plus 1 over 12 x cube plus c. That's the equation for the original function f of x. If you want to simplify it further, we can write square root of x whole cube, okay, plus 1 over 12 x cube plus c. This is the original function f of x, and that's the solution to the question number 8 from the May 2025 P1 paper.